Hello, Unit 6, Day 9. We are writing equations for circles. All right, so in the last lesson we saw how circles have equations in the coordinate plane that allow us to easily identify their radius and center. Okay, the first exercise is a quick review of this idea. Okay, so remember the two equations from the last unit. Okay, this is a circle circle with a center located at the origin, and this guy is a circle not centered at the origin. More importantly, this x1, y1 is the center point. Okay? So, and then also this equation right here would look very similar to that one, right? If we were to utilize the one over there, right? X minus 0 squared plus y minus 0 squared is equal to r squared. Okay? So technically it is the same guy. Except the mathematicians, we simplify that. But it's also important to point out that sometimes you might get something like this, where it might be x squared plus y minus 1 squared is equal to, 25, right? And so, in this case, our center point would be 0, 1, and our radius would be 25. Okay, so just be prepared for situations that arise like that. Okay, so anyway, going back to this one, determine the center and radius of each of the following circles. Okay, so this one's at the origin, so this is 0, 0 with a radius of 10. This one is 5, 2 with a radius of 6. And this one is negative 2, 11 with a radius of 1. Okay, so that's what I wanted you to sort of take away from the last unit. Okay, so now, equations of circles are sometimes not immediately placed in this form. When this is the case, it is difficult to identify their center and radius, right? But the process of completing the square, which you extensively worked with Common Core Algebra 1, not true, right? We were quarantined, but can allow you to place these equations in this form. So first, we're going to review these guys right here. Okay, so make sure you follow this process that I go through. Okay, you always want to start with, well, making sure we have a leading coefficient of a 1, which we do. So we're good in all 6 situations. And then our next step, right, is to send our constants over to the other side. Okay, and once we do that, we take our b value, divide it by 2, and square it. So in this case, our b value is 10, divided by 2 is 5, and 5 squared is 25. Okay, there's a reason why I sort of demonstrate it like that, and I'll explain in just a second, but this is the value we're going to add to both sides of the equation. So x squared plus 10x plus 25 is equal to 39 plus 25, which is 64. And then we factor this guy. This becomes x plus 5, x plus 5. And the reason that why it comes out that way is because what we actually created is what we call a perfect square trinomial. Okay, which means, right, we know about perfect squares, 16, 25, 36. What are these perfect squares, or why are they? 4 times 4, 5 times 5, 6 times 6, right? It's the same number being multiplied by itself twice. So in this case, we don't know what x is, but certainly, if we did, right, this would represent the same number being multiplied by itself twice. But in this case, they're just a couple binomials, but as you can see, they're both the same, which is the whole purpose. And then, after we do that, we get this right here. Right, combine those guys, right? We have 2 of the same, right? Which, to square it means you just multiply them by themselves twice. And then to get rid of that 2, right? To get rid of that exponent, that square, we're going to take the square root, right? So when you do, remember, you get a plus or minus version of that number. And then we subtract 5. And so our answer is -5 plus or minus 8. So x is equal to a -13, and x is equal to a positive 3. Okay? Let's take a look at the next one. So the next one, all right, I'll try to go rather quickly through these, so make sure we're following along here, right? So bring our 7 over. Bring our 7 over. X squared minus 6x is equal to 7. -6 divided by 2 squared, so we're going to get a -3 squared, which will give me a, 9er. Okay? And so, that's the value I'm going to add to both sides. 7 plus 9 is 16. Now, here's a little trick. Right? You see this guy right here? This guy always ends up being what these guys factor to be, x minus 3, x minus 3, right? Which is what we want, right? We want the same thing in there twice. So, just a little hint, right? This number right here always ends up down there, okay? Now we get x minus 3 squared is equal to 16, square root, plus or minus 4, and 3, x is equal to 3 plus or minus 4. So x is equal to 7, and then x is equal to a -1. Okay? Now remember, right, I'm looking at all of these could potentially be factored, right? So the purpose behind completing the square isn't to just torture you guys. It's that sometimes that these numbers that we see here, these numbers, these equations, right, aren't always factorable. All right, so it's important that we know how to utilize completing the square and quadratic, because those both are other ways of solving quadratic equations. Okay, so just keep that in mind, that completing the square is just one way of solving quadratics. There's also factoring and quadratic formula. But for now, we have to make sure we're okay with completing the square. Okay, so I'm going to do one more, and then I'm going to jump down to the later examples. Okay, so this guy again, bring over the 51. So a squared plus 14a is equal to 51. 14 divided by 2 squared, 7 squared is equal to 49. A squared plus 14a plus 49 is equal to 100. Lo and behold, when we go to factor this, what a shocker, x plus 7, x plus 7. There's that value again. Okay, combine these guys. Take the square root. X plus 7 is equal to plus or minus 10. Subtract 7. X is equal to a -7 plus or minus 10. So x is equal to -17. X is equal to a 3. Okay. So hopefully that gives you a little idea. We worked on those in class, so hopefully you guys are okay with those. All right, so let's jump down to some nitty-gritty here. Okay, so this is the whole purpose of where we're going with this guy. All right, so a circle has an equation shown below, not in standard form. All right, so as you can see here, all right, this is an equation of a circle, all right, but it doesn't look as nice as we had before, right? This is called general form. All right, and so general form is pretty much as it states, right? It's just general, right? We don't know anything. We know it's a circle because I see a x squared and a y squared there. Okay, so I know it's an equation of a circle, but it doesn't give us our center or radius, right? So here's what we got to do. It says use the process of completing the square twice to write this equation in standard form. Okay, so what we're going to do is I'm going to complete the square twice with both my x values and my y values. Okay, so first thing you want to make sure is, again, all constants are on the other side. Here's our where we're going to complete the square here, and so we need to make sure that also we have a leading coefficient of a 1, which we do, just like we did up above. And so now we're just going to complete the square for this guy first, and then do that guy right there. Okay, so -4 divided by 2 squared, -2 squared, 4. Must be -8 times 2, or divided by 2 squared, -4 squared, 16. X squared minus 4x plus 4, right? Plus y squared minus 8y plus 16. Okay, so I add those values to the back of the equations like I normally would, except, I had to do it twice. And then whatever you add to one side, you have to add to the other. So 5 plus 16 plus 4. And then you just factor these two pieces here. So this is going to become x minus 2 plus y minus 4 is equal to, looks like 25. This becomes x minus 2 squared plus y minus 4 squared equals 25. And now we have it in standard form. Okay, so it says, what are the center and radius of this circle? Okay, our center is 2, 4, and our radius is 5. So finally we go to graph these guys. Here's my center, 2, 4. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, and 5. So I can get that last part in there. Good enough, right? Make the circles a little bit. There we go. Not my best, but good enough. There we go. And so there is our circle on the grid. Okay, so it says, for each of the following equations of the circles, place them in standard form, and then identify their center and radius. Okay? So for this guy, b value, right? Okay, so we're going to take our b value for the x ones, which is 8 divided by 2 and squared, so that's 4 squared, 16. And the other one is -4 divided by 2 squared, which is -2 squared, 4. All right, so this piece here, I'm going to add 16 to it to create that perfect square trinomial. And then over here, I'm going to add 4 to, again, create that perfect square trinomial out of these two pieces here. And then we add everything else to the other side. So -16 plus 16 plus 4. This factors to be x plus 4, x plus 4. This one factors to be y minus 2, y minus 2. And combine like terms. And our center, -4, 2. Radius is 4. Over here. Okay, again, I got to complete the square for both of these sections to put this in standard form. So, -18 divided by 2 squared is equal to -9 squared, which is equal to 81. And this guy over here is going to be -10 divided by 2 squared, -5 squared, 25. So over here I'm going to add x squared minus 18x plus 81 plus y squared minus 10y plus 25 is equal to -6 plus 25 plus 81. Okay, so hopefully gotten the pattern. This, at least by now, this becomes x minus 9 squared. This becomes y minus 5 squared. And, all right, so negative 6 plus 25 plus 81 gives me 100. All right, so our center, 9 comma 5, our radius is 10. Down below. Okay, take a look at these guys here, right? Finally running into some issues. What do we see? We see a 2 in front of these guys, which tells me, well, tells you too, hopefully, that we don't have a leading coefficient of a 1 here. So what we're going to have to do is we're going to have to, we'll get rid of that 2, right? We're going to have to, simplify, right? How do we simplify this 2? Or how can we get rid of this 2? Well, it's not as bad as you think. I'm just going to divide everything by 2, right? What you do to one side, you got to do to the other. So I'm going to divide every one of those pieces by 2. So when you do, you get x squared plus 2x plus 2y, hey-o, plus y squared minus 2y is equal to 7. Okay? Next thing we're going to do, 2 divided by 2 squared is equal to 1 squared is equal to 1. And negative 2 divided by 2 squared is negative 1 squared is 1. So, in retrospect, I'm only adding a 1 to both equations here. And then 7 plus 2, right, or 1 plus 1 will give me a 9 on the other side. So make sure whatever you add to one side, you have to add to the other. And then this guy factors to be x plus 1 squared. This becomes y minus 1 squared equals 9. Okay, again, where am I getting this from? Remember, this guy factored is just x plus 1, x plus 1. And then this guy factored is y minus 1, y minus 1. Okay, so I'm just sort of skipping through and putting those both together, right, utilizing this number here, okay. And then our center point is going to be negative 1 comma 1, and our radius is 3. Okay, last but not least, same sort of concept, right? We got a leading coefficient of 5s here, so I'm going to divide by 5, and so I get x squared, 70 divided by 5, what is that? 14x plus y squared minus 4y, I can do that one, plus, and then what do we see? 260 divided by 5, that's 52, equals 0. Okay, so a couple issues here, right? We got rid of our leading coefficient. Now I got to move all my constants over to the other side. All right, and then finally, okay, negative 14 divided by 2 squared, negative 7 squared, 49. And negative 4 divided by 2 squared is negative 2 squared, 4. All right, so these are the values I'm going to add to both sides. And again, this is my b value divided by 2 and squared. Okay, this is what I add to both sides. Okay, so this becomes x squared minus 14x plus 49. Plus y squared minus 4y plus 4 is equal to, 49 plus 4 will give me a 53. So, we just made it above the negative mark there, right? Okay, so this guy right here, if we went to factor this would be x minus 7 plus y plus 4, 2. y plus 2 is equal to 1. And then this becomes x minus 7 squared plus y plus 2 squared is equal to 1. So our center point, 7 comma negative 2, radius is 1. And last but not least, okay, graphically solve these. Okay, so unfortunately, we're going to have to complete the square one last time, right? So we can graph this guy. All right, this would be x is negative 1. All right, and we're going up by 1, right? This is y equals mx plus b, right? And so our slope here in this case is just a 1. So go up 1 over 1, up 1 over 1, so on and so forth. Not the straightest line there, but it'll get the job done. Okay, so this last one, we got to complete the square here. Luckily for us, they took care of most of the hard work. All we have to do, divide our b value by 2 and square it, so it's negative 6 squared. That gives me a 36. Then over here, negative 8 divided by 2, negative 4 squared, 16. Okay, so over here I'm going to add a 36, and on the y side I'm going to add a 16, all right, and then negative 27 plus 36 plus 16 is equal to a 25. And this factors to be x minus 6 squared plus y minus 4 squared is 25. And so now we got everything to graph here. Our center point is 6 comma 4, radius 20 or blah 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 5. Okay, so let's draw that in there. 6 comma 4. So 1, 2, 3, 4, 5. 5. 5. 5. Somewhere around there. Close enough, right? Doesn't have to. Trying to make it perfect. Okay. So anyway, and it says graphically solve. We did, right? Any system of equation, okay, what they're asking for, when they say graphically solve a system of equation, graph both, and then here's our solutions, right? Now, that's not asking for the solutions, but our solution is anywhere those two graphs meet. So just remember that anytime they're asking for finding the, or, you know, solving the system of equations, okay, either graphically or algebraically, the solution set is always where those two graphs intersect. Okay? So anyway, hopefully this helps. Good luck, you guys. I'll see